Now let's take a look at handling wastewater. Little footnote. Alice Chalmers in the day defined wastewater as water with soft solids in it. Okay. Sewage, of course, is the other word for it. And mentioning there's a distinct difference between stations utilizing submersible pumps and those utilizing dry pit pumps, even if the latter are in fact, the dry pit pumps are in fact submersibles configured for a dry pit installation. The significant item in wastewater pumping station is valve accessibility. Dry pit station design, other than the wet well itself, involves quite similar approaches to those recommended for water pumping station designs, as you will see. Regardless of pump type, the wet well bottom should be contoured to promote solids being directed to the pump inlets or inlet valves rather than settling out. And here's a good example. You see how the sides are sloped. There's no pockets really where solids can collect. You've got when the pumps are running at a decent flow into the inlet of the pumps, therefore solids can't accumulate in a corner and build up and become a significant problem. That can be rather dramatic on occasion, building up of solids in a square wet well. And mentioning here about another concern is with the discharge, particularly if you've got combined sewers which have rocks and debris in them. They can be pumped through the pump, get into the discharge header, and if you see this one here, this drawing, or pardon me, photo, if the pump closest to us discharges and there's rocks get up and get into that horizontal header, they can fall into the next pump. If it isn't running, can fall into its discharge. That can accumulate and get to the point that then you've got a problem of that pump trying to start, open the check valve, and run. Okay. Now, pump clogging is always a possibility, and besides the selection of pump type, there are a couple of approaches that help. One is using a flapper check with a backflow device. We mentioned this earlier. Then it can be the pump can actually be backflushed, causing a turbine back a bit, but flush out anything that's in it. Warning with the backflow device, there's two different ways of doing it. Some, like APCO, the device does not extend back and down as you unscrew it. It's almost like an unrising stem gate valve, the way it's configured. This one was very close to the floor. Lucky that it did clear, and if it had been anything other, in other words, the kind that actually did unscrew and extend, there wouldn't have been room for it. This has, as mentioned, an indicator light on it so that they can see when the valve is open, the check valve is opened and not. Pump reversal may also help clear clogging. Now, if you're back flushing, but mention this on some pumps. If you've got a variable speed drive, it's very easy to have a forward reverse. It's just single command to the drive. Have it spring loaded so the operator can try running the pump backwards and see if that helps. It sometimes it will, sometimes it won't, but it's nice to have it there. To help clear grinder pumps, and we got into grinder pumps fairly heavy. At the end of their pumping cycle, one trick was to have an off delay timer such that the grinder pump would keep running and literally running itself to the point it can no longer pump wastewater and no solid material is being drawn in, at which point the pump, in theory, can clear itself. And then on the next cycle, ready to go without something already be in it. This is less critical with a three-phase motor because three-phase motors have more torque, and if there's something jammed in there, very often they can overpower it. If you use that approach, basically the pump will airlock unless you have an air release anti-siphon device, which you'll see explained a little further on. Okay. Valve selection. The best choice for wastewater, in my opinion, is the flapper check. Horizontally mounted, not vertical, and provided with the backflow device option. Certainly with larger ones. The proximity switch option, which we talked about, is also appropriate because it allows you to verify A, the check valve is opening, and B, that the pump is actually pumping. In terms of isolating valves, you've got three options. The resilient wedge non-rising stem gate, which is good. ball valves, which are good, and the eccentric plug is good. It comes down to operator preference, but my recommendation would be an eccentric plug valve basically installed with a gear operator, so it can't be slammed shut, uh, and with the valve shaft horizontal such the plug rotates upward, and the seat being closest to the pump on the discharge side to serve as isolation. Okay, we got into that when we were looking at those valves. You can also, on the smaller pump applications, there is a 2-inch flapper check. It doesn't have the options of proximity switch or backflush, but for small applications, individual grinder or recessed impeller, it is the way to go. Now, with those small applications, probably your best choice is non-rising stem gate valves, which very often are metal seated in those sizes, with an extended operator. Suggest using stainless steel for those valves because bronze will turn a weird dark blue in wastewater because the hydrogen sulfide and the copper don't get along. And there's a spec of what would recommend. Submersibles. A typical submersible wastewater pump is rail mounted. You can see in the photo um, to the left and to the right, the pumps are kind of angle mounted to either side of that well or for the ultrasonic. And they're set up in such a way that when the pump is not running, it can be lifted up automatically. In this case, you'd have to raise the gates on that intermediate floor, graded floor, but they can be lifted up right up to the surface, okay? And mentions about how they can be installed. This angle is a bit unusual. Usually they're parallel. At one time, it was very common to have pump-related valves within the chamber, as you see here, and an intermediate floor, as you see, and then a ladder to go down and doing it. However, confined space issues and basic maintenance considerations have led to the valving being located external to the pumping chamber. This goes back to the mid-70s. Some people say new idea, it's not. And you can now get packaged fiberglass stations where there is a chamber just like this, except everything that's shown in steel has been done in fiberglass, wound woven fiberglass, and has that separate valve chamber. And a very similar approach is to have a separate concrete chamber for the valving, having full surface access. If it's not too cold and you're not too deep, you can actually avoid issues of confined space entry because you're not really buried that much. Now, another approach is to have a completely separate below grade chamber, which I guess would be confined space, but you're separated from the wet well. You need ventilation, but and wastewater relate. One of the problems is if you follow, and you can see on the right hand side back, there is a valve flapper check with the screw backflush device on it. The only pursuing backflush the pumps, which were submersible, and you see the little light on top there in that gray enclosure. The only problem is that the two discharge lines come together and then pump down. Well, obviously that's a spot where air can trap, so you end up putting a wastewater rated combination air release valve. The wastewater related air release automatic air and combination valves, what it is the float would be at the bottom of that chamber that you can see, and the mechanism up at the top. And they figure that way the wastewater sewage will never actually get into the mechanism itself. And most of the time. They're a little bit of a bear, but you've got no choice if you've got that kind of an arrangement. With large stations, separate valve chamber is the best way to do it. And you saw the little blow up of the backflow actuator close up floor. Here again, they followed the balcony approach. So you've got a balcony that you can walk along, and to get down to where the valves are, you go down a little ladder. The quick connect that is commonly used with submersible pump, if it ever seals clear. Now, a lot of them metal to metal seated do leak all the time, a little bit. And that actually can be a bit of a backhanded advantage because it allows any air trapped in the pump to leak out right where that slide connection is. The problem is that some don't leak enough, and or the gap, if the pump's been in for a while, can fill up with solids, at which point, when a pump is not running, you see this in this photo, there's an awful lot of air because of the splashing, an awful lot of air is going down, and guaranteed that will go rise up into the pump. And it can get to the point where it simply displaces the water, pump goes to start, the pump won't start. Well, it's starting, it's spinning, but it isn't pumping because it's airlocked. Okay. Another situation very similar to that is if you have a very low system, you know, low low static head, and in fact, I've seen some where it's actually a negative static head. Pumps are doing nothing but overcoming friction. And what happens is when the pump stops, the inertia of the thing will keep going, and because of that, even though the pump has been turned off, there's still sewage, wastewater is being drawn into the pump, and eventually it can pump the wet well dry just from the inertia of that particular unit, draw the wet well dry, at which point water falls out of the pump, air goes in, and you've got an airlock pump. Okay, solution to both those problems, which is also a device very often seen with the smaller units, is to have a swing check valve set up, cover down, flow towards right to serve as an air release anti-siphon device. Okay, and it's an old trick, but it's a good trick. Here you can see on the riser from the submersible pump, above liquid level, you put a little branch connection, okay? And you've got a check valve mounted such that the check flow would normally be right to left into that header, and sitting and mounted upside down. What happens is that when the pump stops and the column wants to go down, that will open like a check valve would. It'll open, and the weight just kind of helps it, and basically break any vacuum that's being created from inertia, whatever. It sits there like that with the weight of it down. Therefore, any air that gets into the pump will bubble up through that riser where it says from pump, which is the discharge, and any air will go out to the side through that check valve because it's upside down, and the weight of the flapper is keeping it open. Now, when the pump starts, they say, well, yeah, the sewage will hit it. Usually what happens is when a pump starts, there's enough of an airflow, and the airflow alone will pop it up. It's a very simple, crude little system, but boy, it can save some very significant problems. And there's a spec of what we're talking about. Interesting thing with small sump pumps, they will actually put a little bleed hole in the case, and it's built-in leakage, but again, that breaks any siphon, and also allows any air that gets bubbled into it to simply be vented out. In a sewage wet well, you can put in a washdown platform. This is on a large station. And basically, you can have a kiosk with a quick hose connection. And the only thing is, of course, you need a reduced pressure type backflow preventer installed above grade for that hose water supply. And I mentioned here, I've actually seen a situation where they put in a reduced pressure zone backflow preventer in the wet well below grade, and basically the anti-siphon port and everything else potentially could be flooded with sewage, in which case you've got the potential of a backflow situation into your drinking water supply. Okay, bad. Again, it's one of these things. You're not only what makes the pumps happy, what makes the water system happy is a consideration. And as with most pumps, unusual stations designs. This apparently was one that was built in Houston, and you can see how they've got umpteen different pumps actually simply pumping up and discharging into a inner chamber, and by picking up the head in that, they get sewage flow. Dry pit pumps. Quick comment. Dry pits at one time were very common. Submersibles have tended to come in and dominate. Um, where you draw the line between the two, some people really, certainly as they get bigger, you can get very big, hundreds of horsepower submersibles. Similarly, you can get small dry pit. Where you draw the line, a lot of it is operator preference. Um, but draw your own lines and conclusions. You probably 250, 300 horses, probably about the point you maybe should be thinking dry well. Hard to say though. A lot of it preference, operator preference. Now, dry pit wastewater pumps inevitably are installed vertically. The horizontal is kind of a useless configuration with individual inlet lines from an adjacent wet well and a common discharge header. And as we mentioned before, you've got the situation of using an elevated header, a trench mounted, or balcony type arrangement with an elevated header. Again, as we mentioned, watch out for rocks with combined sewers that can go and fall into the adjacent downstream pump. At one time, it was quite common that to use duplex in a below grade dry pit chamber. And just draw this, you had a central entrance tube, D is the dimension of the shaft, and you came down the ladder there, and there was ventilation to keep it vented. You're between the two pumps, so they were accessible. The check valves and whatever were sort of behind the ladder there. And you had a control panel with a sump underneath it, dehumidifier to keep it dry. Dehumidifier, by the way, is almost like a refrigerator, except it cools and then heats it right back up again. What does that accomplish? Well, when it cools, you get condensation. That's how it dripping out, pulled out of the air and drips out. That's why the cooling thing. And then immediately it's rewarmed. That's a dehumidifier's operation, okay? Any vertical mounted end suction pump with low pressure inlet, which you're getting from a wet well, is susceptible to air locking, particularly if incoming wet well lines cause splashing. We saw that before, and get air entrained. Therefore, the design of each pump inlet line is you should have any reducers eccentric so that there's a flat right along the top of them, so air can't trap in a pocket. It'll be forced, generally follow back to from the beginning. Anyway, that's the thing, not to use concentric, but use eccentric reducer. You see the two white arrows. Anyway, one of the things I like to do is a little different in using grooved end, i.e. Victaulic fittings, is rather than elbows and everything, simply come back with a T, a inlet line size T with a cap at one end and a reducer at the top, which then fits up against the pump itself. What that accomplishes a couple of things. Number one, because the reduction is right at the pump inlet, pumps like that. They like that rather than having an elbow or a situation where you're going to strike laminar flow. Turbulence right at the inlet by that. Plus you have the option of pulling, if you really get something caught in the line, of pulling that removable cap and just having straight access to the line. This was an installation that was kind of interesting and had that arrangement below each of the three pumps. And there were, I think, 150 horse pumps. It had been a dry well at one time with shaft-driven pumps, and there were 30 some odd feet, and for a number of reasons they wanted to get rid of it. So what we ended up doing, basically you can see the discharge of the pump just sort of off to the left, using again flapper type check valves. The valving, because it was so confined, you're going from what was strictly a discharge situation to actually having significant inlet arrangement, because lines were too small. We actually have to arrange sort of a plenum chamber by interconnecting them. So we used knife gate valves with the operators above. So there's my charming wife again, actually standing on a grated platform that was about a meter, about 3 feet above, so that a lot of the inlet piping and everything was down below, but the actuators for the valves were up there. And of course, there's the pumps. easy enough to service them by lifting, and then everything is right there. Interesting job. Just a random collection of sewage pump stations. This is Clover Point over in Victoria. You notice they had standard swing check valves, and behind them, or on the discharge side, a eccentric plug valve, but mounted shaft vertical. At least they had an isolating valve, and you'll see why I say that. This is a station in Vancouver called Clark Drive. You notice the long shafts. The motors are up atop, above, and these like drive shafts come down. You notice they do have guards in case the U-joint lets go, that the shaft can't swing out, and as happened once upon a time, actually did kill somebody. Okay. This is Terminal Avenue Station in Vancouver. One of the problems back in the day, the valve manufacturer representative, they had these cylinder operated pump control valves. Start against the closed valve, which then slowly opened, and then on shutdown the pump remained running as this valve closed, and just before it closed, limit switch would turn the pump off. And they said, well, yes, if you need to work on the pump, this valve can be overridden and closed. Great, so you don't need an isolating valve beyond that. It is a combination of both a pump control valve and an isolating valve. Yeah, right, except it is operating a lot. And what happens when those valves fail? In other words, get to the point they need maintenance, you don't have an isolating valve. And that was a big problem with them. So no, it should have had a separate isolating valve. However, we get smart with age, I hope. Pressure relief. People talk about providing wastewater pressure relief valves. I quote this from, and again, I think this was U.S. Corps of Engineers. The pressure rise which would occur with a simple check valves and without water column separation, I'll come back, is approximately equal to the initial pressure drop at the pumps, with a maximum of about static head. So that's not any great amount of pressure to worry about. If you can't handle static head, you got real problems. If no check valves were provided, and if the reverse flow was allowed to pass through the pumps, the pressure could rise to a maximum of about 50% of the pumping head, depending on the inertia of the water column, rotational inertia of the pumping units, and the pump characteristic. So even if the pump turbine back, you're not going to get a significant amount of pressure. Now, if you're worried about, water hammer, you can either control the speed of the pump, use soft starts, etc., etc., etc. If you're using a pump control valve, all of those work fine, except the one little comment there: without water column separation. That is where sewage force mains get blown up. If you have water column separation, and we saw that earlier, then you can have a problem. That is where it helps to have a soft stop arrangement or variable speed, whatever, or pump control valve. If you prefer that, I think that its day is done. But anyway, and do appreciate, though, if there is a power failure, liable to get column separation because it's immediate. But again, your odds are a lot. If you've got a flapper check that can close fairly quickly, you should be all right. And wastewater pressure relief valves can be a real pain. As I say, suggest a pump discharge slow opening actuated eccentric plug valve is one approach, as it does allow reverse flow. And the actuator must close the valve on power or pump failure and have hydraulic dampening, Air doesn't, air can compress. And I have seen the situation where a wave can come back, slam an eccentric plug valve closed, and then immediately spring back because of the air, and you get a spike in pressure. So it needs to be either hydraulically powered or have a hydraulic dampener on it, okay? And it goes into the details on that. The pump discharge control check valve is, if column separation is likely and you're worried about it, it does have that advantage Now, what will happen is because it's slow closing, there's a power failure. Effectively, the inlet side of the pump becomes the relief area, and flow will come, and instead of being, you know, relieved separately, it'll go right straight through the pump. A pump goes along with the flow. They say, well, when the power quits, the pump will immediately stop. No, it will not. It will play turbine, flow can go through it, and there's no real problems at all as the thing slowly valve closes and away you go. I hope you found that interesting, and have a good day.